in Texas. Good morning. Here we are. AP Calculus 2018 Unit 2 Test Review, and I already explained number 1 and number 2 on a prior video, so we're on video number 2. We're going to do the FRQ 3. So what's the FRQ going to be like? It could be like any of these. So these are our practices. Are you ready? The key here is that you need to know, am I analyzing a derivative and answering questions about the original function, or am I analyzing an original function and answering questions about the derivative? And we're going to go flip-flop in your head with those memorization facts. So question 3, the derivative of a polynomial function f is represented by the equation f prime. So class, are we given an original or the derivative? The derivative. And then we have an additional fact here. Use this information to answer the following questions. Notice that every question we're analyzing the original, we're answering questions about the original function given the derivative. Here we go. At what value of x does the graph have a maximum? The graph will have a maximum at a critical number where the derivative goes from positive to negative. So we have some work to do. These used to be full pages and I squished them up to save paper, okay? So you can either write really small or use lined paper. I'm going to write really small on these papers. Do you see this derivative here? It's already factored for us. So a lot of times you have to find the derivative yourself, factor and solve it. But do you see how it's already factored? So step 1, you need to have this step memorized. Step 1 is I need to find the critical numbers. So the critical numbers will be when the derivative is equal to 0. So that's going to be x equals what and what? What are the two solutions to this set equal to 0? Whenever there's an x by itself here, we get a 0 from that. So x is equal to 0. And then what's the solution to x minus 3 equals 0? 3. Yep, positive 3. And I froze. What do we do with these critical numbers? Critical numbers 0 and 3. What do we do with them? We're going to make that little chart. See how itty-bitty my chart's going to be? Itty-bitty. I know, or I'm pretty sure that I'm going to have a max or min at 0 or 3, but I got to figure it out which one is which. No guessing. We got to do some math. So what we're going to figure out is if the derivative is positive or negative in these 3 intervals. So for all the x's less than 0, will my derivative be positive or negative? And then between 0 and 3, and then greater than 3. So pick a number less than 0. -1. Good. Now we're going to plug that into the derivative. We don't need to know the answer. We just need to know if it's positive or negative. But if you are not into mental math today, we can plug it in. So let's plug in -1. So negative times a negative. What's a negative times a negative? Positive. And what happens to anything we square? What's that going to become? Positive. So the derivative is positive. See how quick we do that? Let's plug in a number. What's between 0 and 3 that we can plug in? 1. So let's plug in +1. And we have a negative times a positive. It's a negative. And then anything squared is a positive. So I have negative times a positive is a negative. So all the numbers between 0 and 3, the derivative will be negative. What's a number greater than 3? 4. We're going to plug that into the derivative. So we have -2 times 4. -2 times 4 is negative, and then anything squared comes out positive. So I have a negative times a positive, which is negative. Okay, there's our work. Now we get to answer the questions. At what values of x does f of x have a relative maximum? So a maximum will be when the derivative switches from positive to negative. Look at your chart. Does the derivative switch from positive to negative? Where does that happen? At 0. So we say in a complete sentence, f will have a relative maximum at x equals 0 because f prime of x changed or changes from positive to negative. Does f have a relative minimum anywhere? Does the derivative ever switch from negative to positive? No, so we would say no minimum. You can't just leave it blank. You can't leave it unanswered. It will, be ready, my friends. It will say, hey, where does f have a minimum? And your answer is, there is no minimum. That's okay. So don't think, oh my gosh, it has to have an answer. I have to have an answer. The answer is there's none. Okay. What intervals is the graph increasing and decreasing? All we're going to do here is explain the chart. Okay. So we have our chart. That's like our show your work part. So f is increasing. F is increasing on an interval. So where is f increasing? Negative infinity to 0, good. And the reason, we have to explain everything, because the derivative is greater than 0. F is decreasing on 0 to infinity. Okay, do you see how the derivative is less than 0 and less than 0? Even though the derivative equals 0 at 3, it's actually still decreasing the entire time. So it never is increasing, thus it's decreasing from 0 to infinity. All right, did we finish that? Sweet. What's the equation of the tangent line? That's like half of this test. Half of this test is the equation of the tangent line. The other half is analyzing f and f prime. Okay, so what two things do you need for an equation of a tangent line? We need a slope and a point. Yes? So first we need the slope of the tangent line. How do you get a slope of a tangent line? What do you use? The derivative. We're going to say the derivative. The slope of the tangent line is the derivative. So we have the derivative. And did they give us an x value? They have to, okay? So the slope of the tangent line will be when we plug 1 into the derivative. All right, let's try and find that answer. This one step. -2 times, what's this? Oh, this is also -2 squared. So -2 squared, we got to do the exponent first, is 4 times -2. So -8. Now we need a point, so we need a slope, but then we also need a point of tangency. We have an x value here. Now we're given the y value or we have to find the y value. Were we given it or do we need to find it? Look in your question, go on a scavenger hunt. I can't plug it in here, that would give me slope. Additionally, so are we given the y value? Yeah. Now that we have the slope and the point, we can write the equation of the line. Y minus y1 equals m times x minus x1. When you subtract a oops, I made a mistake. Yeah, because I'm thinking about the next item. Our x value is 1, so we're going to have x minus 1. Okay, last question. Use the equation of the tangent line to find an approximation of f of 1.1. You should be able to do this without a calculator by plugging it in here. I don't like to solve for y if I'm going to plug in this decimal because it's much easier to plug it into point slope form. So go ahead, you try that. Try plugging it in. All right, so when we plug in 1.1 and subtract 1, we get 0.1. Now this should be very simple. Negative 8 times 0.1, I still have y, plus 3 on the left. This will be negative 0.8, because 8 times 1 is 8. Just write that down. The goal is to find y, so we're going to subtract 3. Luckily these are both negative, so I know when I do a negative minus another number, we add them and keep the answer negative. Okay, what is this called? What is that number called? This is called the approximation, tangent line approximation. All right, I have some time, so I'm actually going to do a, I don't have any, where are we? All right, so I'm going to do 2 on the back here. Y'all ready? If g of x equals this, then the slope of the line that is perpendicular to the tangent line at x equals 1 would be. Welcome to calculus when you have to do like 8 problems in one little problem. So, you ready? Get set. What do you think we should do first? You saw the word slope. So what do you think when you see the word slope? Derivative. Step 1. Derivative. You can never start with the answer, you guys. You don't know what the heck, I don't know what the heck we're going towards. I just know what can I do? What math can I do? Well, I know I can take a derivative, and the title of this test is derivative. So I'm going to start with that. There's my derivative. And they gave us an x value, so what should we do with that x value? What should we do with it? Plug it in, yeah? I mean, what else would you do with it? Take it dancing? All right, let's plug it in. And remember when you square first, so we're not squaring the 9. It's 1 squared times 9. Now, ask yourself, what is this number? I should know this number. I should know what g prime of 1, what does this mean? A slope of what? Okay, now let's go and read the question. If g equals this, then the slope of the line that is perpendicular to the tangent line would be, it's -4, right? The answer is B, -4, because that's what I got. Is that right? No. This is the slope of the tangent line. What would you get for your perpendicular slope? Opposite reciprocal. So if it's -4, it's going to be positive 1/4. Opposite reciprocal. That was on the quiz. All right, one more if we have time. The equation, blah, 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 represents the equation of the tangent line drawn to the graph of g when x equals -1. What is the value of g prime of -1? Okay. G prime of -1 means, what does this mean? What's the definition of that? Anytime you have a derivative with a number here, that's going to be the slope of the tangent line. And what are we given? What is this? This represents what? The equation of the tangent line. If we were to rewrite this in y equals mx plus b, and then look right here, would we have the slope of the tangent line? Yeah. So we're out of time. I'll pick up the third video with this question.